Hello everyone, welcome back to Success Mantra. In this video, we will discuss about the relationship between zeros and coefficients of a polynomial. So we will take a linear polynomial first. We know that the general form of a linear polynomial is ax plus b. In order to find the zero of a linear polynomial, we have the equation minus of constant term divided by coefficient of x. In this expression, the constant term is b, so minus of b divided by coefficient of x. Here the coefficient of x is a. So we have the relation minus b by a in order to find the zero of the linear polynomial ax plus b. If you are considering a quadratic polynomial, the general format is ax square plus bx plus c, and so consider alpha and beta as two zeros of this polynomial. Then the sum of the zeros of this quadratic polynomial is equal to alpha plus beta, that is equal to minus of coefficient of x divided by coefficient of x square. From the expression, coefficient of x is b and coefficient of x square is a. So we have sum of zeros alpha plus beta is equal to minus b by a. Similarly, product of zeros of the quadratic polynomial alpha beta is equal to constant term divided by coefficient of x square. Here the constant term is c. So c divided by coefficient of x square, that is a. So the sum of zeros alpha plus beta is minus b by a, and alpha beta is equal to c by a. So moving on to a question, find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients. So first of all, in order to find the zeros of this quadratic polynomial, we have seen in the last videos that we will equate the given function to 0. So we equate the given polynomial to 0, that is x square plus 7x plus 10 is equal to 0. Now 7x can be written as 5x plus 2x. This you have learned in class 9. Then from the first two terms you can take x as common. So x multiplied by x plus 5, and from the remaining 2x plus 10 we can take 2 as common. So we get 2 into x plus 5. So we get x plus 2 into x plus 5 is equal to 0. That implies x is equal to minus 2 and minus 5. So we get that the zeros of this given polynomial is minus 2 and minus 5. In the question they have asked us to verify the relationship between zeros. So we want to prove alpha plus beta and alpha beta. So sum of zeros of this quadratic polynomial alpha plus beta is equal to minus of coefficient of x divided by coefficient of x square, that is minus b by a. So here the two zeros are minus 2 and minus 5. So minus 2 plus minus 5 is equal to minus of coefficient of x. From the question, coefficient of x is 7 and coefficient of x square is 1. So we will write minus 7 by 1. So here minus 7 is equal to minus 7, that is LHS is RHS. So we have proved the sum of zeros relationship. Now we want to prove the product of zeros relationship. So we will take product of zeros of the quadratic polynomial alpha beta is equal to constant term divided by coefficient of x square. From the given polynomial, the constant term is 10 and coefficient of x square is 1. So we will write minus 2 into minus 5 is equal to 10 by 1. That is 10 is equal to 10. LHS is equal to RHS. So we have proved the product of zeros relationship also. So next is a very similar question to the previous one, that is to find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and the coefficients. So we need to first equate the given polynomial to 0. So we will write x square minus 3 is equal to 0, which can be written as x square minus root 3 the whole square is equal to 0. This is of the form a square minus b square. So we will write as a plus b into a minus b. That is x plus root 3 into x minus root 3 is equal to 0. That implies x is equal to root 3 or minus root 3. So the zeros of the given polynomial are root 3 and minus root 3. Now we need to prove the sum of zeros of the quadratic polynomial alpha plus beta is equal to minus of coefficient of x divided by coefficient of x square. So we will write root 3 plus minus root 3 is equal to, here coefficient of x is 0. So we can write minus of 0 divided by coefficient of x square, that is 1. That is root 3 minus root 3 0 minus 0 by 1. Any number divided by 0 will be 0 only. So right hand side is equal to left hand side. So we have proved the sum of zeros of the quadratic polynomial function. Now we will prove the product of zeros of the quadratic polynomial, that is alpha beta is equal to constant term divided by coefficient of x square. Here constant term is minus 3. So minus 3 divided by a, that is 1. So we will write root 3 into minus root 3 is equal to minus 3 by 1, that is minus 3 is equal to minus 3. So we have proved the product of zeros of the quadratic polynomial. So moving on to the next question. Find a quadratic polynomial, the sum and product of whose zeros are minus 3 and 2 respectively. That is, we need to find the quadratic polynomial here, and a clue given in the question is that the sum of zeros are minus 3. That is, alpha plus beta is equal to minus 3, and product of zeros are 2. That is, alpha beta is equal to 2. So from this, we need to find the quadratic polynomial. So first of all, we will write the quadratic polynomial be ax square plus bx plus c, and alpha and beta be the zeros. Now we need to find the value of a, b and c in order to get the quadratic polynomial. From the question we can write alpha plus beta is equal to minus 3, which is also equal to, we know that, minus of coefficient of x divided by coefficient of x square, that is minus b by a. So if we compare minus 3 with minus b by a, we can write the value of b as 3 and a as 1. And from the question we can write alpha beta is equal to 2, which is equal to constant term divided by coefficient of x square. So 2 equal to c by a. So from that we can write c is equal to 2 and a is equal to 1. So we got the values of a, b and c. Now we substitute this in the general equation to get the quadratic polynomial. So if a equal to 1, then b equal to 3 and c equal to 2. So one quadratic polynomial which fits the given condition is x square plus 3x plus 2. Now we will check the relationship between zeros and coefficients of a cubic polynomial. So we will consider a cubic polynomial first, ax cube plus bx square plus cx plus d, with alpha, beta and gamma as zeros of the polynomial. We know that zeros are equal to the degree of the polynomial. Here degree is 3. So we have 3 zeros. Let it be alpha, beta and gamma. Now sum of zeros of the cubic polynomial, that is alpha plus beta plus gamma is equal to minus b by a. That is minus of coefficient of x square divided by coefficient of x cube. Now sum of product of any two zeros of the cubic polynomial, that is alpha beta plus beta gamma plus gamma alpha is equal to c by a, that is coefficient of x divided by coefficient of x cube. Now product of zeros of the cubic polynomial, that is alpha beta gamma is equal to minus d by a, that is minus of constant term divided by the coefficient of x cube. So let's do a problem on it. So verify that 3 minus 1 minus 1 by 3 are zeros of the cubic polynomial p of x is equal to 3x cube minus 5x square minus 11x minus 3, and then verify the relationship between zeros and the coefficients. So first of all, we need to prove that 3 minus 1 and minus 1 by 3 are the zeros of this polynomial. Then the relationship between sum and products of the zeros. So in order to prove that these are zeros of this polynomial, just put the 0 values in the place of x, and if the result is 0, then they are zeros of the cubic polynomial. So let's do it first. That is, we have given p of x is equal to 3x cube minus 5x square minus 11x minus 3. First we substitute the first 0, that is 3. P of 3 is equal to 3 cube minus 5 3 square minus 11 into 3 minus 1. We got 0. Since the result is 0, 3 is a 0 of the given polynomial. Now we substitute minus 1 and we are ending with a result of 0. So minus 1 is also a 0 of the given polynomial. Now we substitute minus 1 by 3. On substituting we get 0 here also. So 3 minus 1 and minus 1 by 3 are zeros of the given polynomial. If they are zeros, now we need to prove the relationship between zeros and coefficients. So we take alpha as 3, beta as minus 1 and gamma as minus 1 by 3. First relation is alpha plus beta plus gamma, that is 3 plus minus 1 plus minus 1 by 3 is equal to 5 by 3 that is equal to minus of 5 by 3 that is equal to minus b by a. Just to double check it. Now we will do alpha beta plus beta gamma plus gamma alpha. We will get the value as minus 11 by 3. We can verify it. Minus 11 by 3. Is it correct or not? Minus 11 divided by 3. C by A relationship. Now the last one is alpha beta gamma. We need to know whether it is equal to minus d by a. On substituting alpha beta gamma value 3 into minus 1 into minus 1 by 3, we will get 3 divided by 3, that is minus of minus 3 divided by 3. We can do that. So we will get minus 3 divided by 3. So we have proved that the relationship between zeros and the coefficients of the polynomial. Thank you for watching my video, and the next video we will work out more problems on the relationship between zeros and coefficients of a polynomial.